High in Colorado's foothills, a colossal dam is rising, the tallest of its kind in the nation. Its asphalt core structure is so rare that only one other exists in the United States. Beyond this engineering marvel lies a deeper story. Why would a state already dotted with reservoirs pour over $500 million into a new one? The answer lies in Colorado's greatest paradox, a booming Front Range population where water is scarce. While most of the state's rivers flow west, after 2 decades of planning, lawsuits, and construction, Chimney Hollow Reservoir is preparing for its first fill, marking a new chapter in Colorado's water history. Yet its future faces climate change, environmental battles, and the surprise discovery of something unexpected deep in quarried rock. More than a dam, it is a test of how far society will go to engineer certainty in a water-stressed future. Colorado's Water Challenge. Colorado's relationship with water has always been defined by scarcity and imbalance. Though the state is the birthplace of the mighty Colorado River, most residents live along the arid Front Range, far from flowing rivers. This mismatch has driven a century of trans-mountain diversions, tunnels, and reservoirs designed to move western slope water east. The Colorado Big Thompson project, completed in the 1940s, was the first major feat, followed in the 1980s by the Windy Gap project, which pumped additional water into Lake Granby. Yet Windy Gap exposed a weakness. It lacked dedicated storage on the east slope. In wet years, water could be moved, but in dry years, yields vanished, leaving cities with rights they could not count on. As Front Range populations exploded in the early 2000s and climate change made snowpacks and runoff increasingly erratic, communities like Broomfield, Longmont, and Loveland demanded reliable, firm supplies to secure their future. The solution was clear: build a new reservoir to stabilize Windy Gap water and ensure year-round delivery. Planning for Chimney Hollow, initially called the Windy Gap Firming Project, began in the early 2000s with an environmental review in 2003. A final environmental impact statement arrived in 2011, followed by federal approval in 2014. After lawsuits and mitigation agreements, the Clean Water Act permit was issued in 2017, leading to groundbreaking in 2021. Scope and features. Chimney Hollow Reservoir is one of Colorado's most ambitious water storage projects. Located west of Carter Lake, it will hold 90,000 acre-feet of water, about 29.3 billion gallons, enough to cover Manhattan, New York City, in more than 12 feet of water, or supply roughly 300,000 households annually. The reservoir spans 760 surface acres with a maximum depth of 325 feet, transforming a dry foothills valley into a critical water bank for northern Colorado. At the heart of the project is the main dam, a 350-foot tall asphalt core rockfill embankment, making it one of Colorado's tallest dams and the highest asphalt core dam in the United States. This primary structure is supported by a saddle dam at the southern end, which provides additional storage. A 5,000-foot concrete spillway channels extreme floods safely, while an inlet-outlet tower and tunnel system connect the reservoir to the Colorado Big Thompson network. Through these works, water from the west slope can be pumped, stored, and released into Carter Lake and Flatiron Reservoir, providing a dependable 30,000 acre-feet of water each year. The project is not just about supply. Surrounding the reservoir, the 1,847-acre Chimney Hollow open space will eventually offer hiking trails, shoreline fishing, and wakeless boating. Chimney Hollow thus serves both as a utility for 12 municipalities and water districts, and as a public recreation area for a fast-growing region. Construction and engineering. Building Chimney Hollow has been a modern engineering feat. Construction began in 2021 under Barnard Construction, with a Swiss firm handling the specialized asphalt core and Nicholson Construction managing the grout curtain. To supply the enormous material requirements, a quarry was opened on site, briefly becoming Colorado's largest mining operation. Millions of cubic yards of rock were blasted, crushed, and compacted to form embankment shells and concrete aggregates. The site lacked sufficient clay for a conventional core, so engineers designed an asphalt core rockfill dam, a rare structure in the U.S. but widely proven in Europe, making Chimney Hollow a landmark in American dam engineering. Hydraulic asphaltic concrete was used for the core due to its impermeability, freeze-thaw resistance, and flexibility under settlement, reducing long-term risks. A dedicated on-site plant produced the material, laid in over 500 one-foot lifts, each compacted with surrounding rockfill. The core and shells rose as a single integrated structure, anchored into bedrock with a grout curtain and reinforced concrete plinth. The asphalt spine is both watertight and self-sealing. By mid-2025, the core was complete, with supporting elements built alongside. Initial filling is expected to begin in late 2025 and will continue in carefully staged phases over several years, with gradual snowmelt diversions monitored for slope stability, seepage, and water quality until the reservoir reaches full capacity. Cost, funding, and timeline. The project carries an estimated price tag of $720 million, making it one of the most expensive water infrastructure initiatives in Colorado history. Funding comes entirely from its 12 participating cities, towns, and water districts, each contributing proportionally to the storage and supply they will receive. For example, Longmont invested around $60 million for 8,000 acre-feet of capacity, while Erie pledged $44 million. No state or federal funds were used. The reservoir is preparing for initial filling, with the first diversions of snowmelt expected once regulatory checks and water quality monitoring are complete. Filling will proceed gradually, a standard safety practice for new dams, with the reservoir expected to reach full capacity of 90,000 acre-feet by 2027. At that point, dependable annual deliveries to participants will officially begin. An unexpected discovery. No mega project is free from surprises. In mid-2025, while quarrying local granite, naturally occurring uranium was discovered. As the reservoir fills, water may leach uranium from the rock, potentially raising concentrations. While uranium is naturally present in many Colorado rocks and waters, officials are monitoring whether levels could exceed the federal drinking water standard of 30 micrograms per liter. Northern Water and the Colorado Health Department paused initial releases, requiring additional testing and modeling. Officials emphasize that water will be treated before reaching households, and concentrations should decline over time. As of August 2025, geochemical studies and monitoring continue, with regulators yet to clear full filling. Criticisms and controversies. Beyond uranium, Chimney Hollow has faced criticism. Environmental groups argue that another trans-mountain diversion increases pressure on the already over-allocated Colorado River, especially amid mega-droughts and shrinking flows. They advocate conservation, efficiency, and reuse before building new storage. Critics also warn of further harm to fish and aquatic habitats, noting the river has been heavily modified by existing dams and diversions. Legal challenges targeted federal permits, but courts upheld them after Northern Water agreed to mitigation. Cost has also sparked debate. Spending hundreds of millions on a reservoir is seen by some as risky when climate change may reduce Colorado River flows. Ethical concerns arise, questioning whether booming Front Range cities should continue drawing more from the western slope. Future outlook. Despite criticisms, Chimney Hollow promises significant benefits for northern Colorado. Its greatest value lies in transforming unreliable windy gap supplies into a dependable source, allowing cities to plan, reducing shortages and emergency rate hikes, and giving water managers flexibility during drought years. The project also creates public amenities. Larimer County will manage over 1,800 acres of open space with trails, fishing access, and wakeless boating, expected to open by 2027-2028. As Chimney Hollow shifts from construction to operation, it will be closely watched. If successful, it will demonstrate that innovative dam technologies can work in the U.S., and that modern reservoirs can coexist with environmental mitigation. For participating cities, the reservoir is expected to serve as a backbone of supply for decades. Yet challenges remain. Climate change threatens to shrink Colorado River flows, and tensions over trans-mountain diversions are likely to intensify. Chimney Hollow will not end the state's water debates, but may sharpen them, standing as both an engineering achievement and a symbol of Colorado's trade-offs in water management.